Hi there, welcome to another video. Today we're going to be looking at binary conversions, hexadecimal, and addition and multiplication division. Okay, so today what we're looking at is another recap on why binary is specifically used in computing, converting between decimal, hexadecimal, and binary, understanding and be able to apply binary shifts, and perform addition on binary numbers. I have talked about this in another video. Why is binary used in computing? Well, okay, so quite simply, binary has two states, on or off. And because computers are made up of switches, this is why binary is used. It can represent voltage. Okay, so base 2 just means you have sort of two options to choose from. So decimal would be a base 10, as there's 10 different symbols you could use to represent something. So throughout this video, you may see that crop up. But binary is base 2, as you have two symbols to choose from. And this represents voltage, like I've said, representing on or off. Just a fun fact here. This symbol is often used as the power symbol, and you can probably see that it looks like this. However, if you break that down, it is a 0 and a 1 combined. Okay, so I've got some Roman numerals here. Why have I got that? Well, I just want to demonstrate that just because we tend to use sort of decimal as a number system, that's not the only one that exists. So, I've missed 7. So basically we have these symbols to choose from when we want to represent an amount. However, if I was writing in Roman numerals, well, I would, for example, writing the number 2 would look a lot like this. That is the same as writing this symbol, and if we're writing in binary to represent the number 2, it would be 1, 0. So all of these are just different number systems. It's really important that you understand that to be able to convert between the two. Okay, what I'm going to do now is I'm just going to show you how I would convert between decimal and binary. Then I'm going to set you off on a task. Okay, so hopefully you've seen this grid before. This is what we use to sort of convert between decimal and binary. So I've got the placeholders along the top, and all I'm going to do is if I want to sort of add the number at the top, I'm going to put a 1 underneath. So, for example, if I wanted to represent the number, let's go for 36. These two numbers are too large, so I'm going to put 0. When we're making the number 36, well, 32 fits in there quite nicely. And what number do I need to bring it up to 36? Well, it's 4. The rest can be zeros. So let's just double check that. 32 add 4 is 36. Okay, so just a quick sort of tip really. If you ever forget sort of your placeholder values, just remember it is double or times 2 of the last number, of the last value. So double 1 is 2, double 2 is 4, keep going, and yeah, that's pretty much it. So let's say I want to go the other way now, and I'm going to try and convert this number here. I have no idea what this is, I'm just plucking it out of thin air. Okay, all I'm going to do is start from this side, and I'm going to place those numbers underneath. So 1, 0, 0, 0, 1, 0, 1, 1. And so it's really important that you're putting the number 1 under the correct value, otherwise you will get a different number. This is why I always draw out the columns with the lines in between, so I can mark it off as I go. So all I'm going to do here is do a quick load of addition. So 128 adds 64, 16 and 1. So the only ones I'm adding up is the ones with 1s underneath. Okay, so that adds up to 209 in decimal. However, it is 11010001. So as I say, these things are interchangeable. Okay, so something really important to remember, Always start with the right hand side with your place values, always start with the number 1 and just keep doubling. Okay, this way you don't need to remember sort of this whole pattern. Just know if your mind ever goes blank, you're just timesing 2 by the last number. So I have a task for you. I'd like you to pause the video now and see if you can answer all of these questions, and I'll see you in a minute. Okay, so hopefully you have worked all of these out. I'm going to give you the answer in just a second. Firstly, I did just want to run through question 5 because I did put that in there to test you a little bit. What's the largest number you can represent with 5 bits? Well, 5 bits here, and I'm adding every single one. Okay, you will see that that adds up to 31. That is the largest number you can represent with 5 bits. And just one final thing from me, obviously always starting on the right hand side. You may have spent some time on question 9. Well, I put that in there just to see if you could work that one out. If it is over 255, well actually what are you going to do? Well, we're going to do the same thing we've always done. We're going to double the amount on the placeholder, which will give us 1, 0, 0, 0, 0, 0, 0, 0, 0. So now we're looking at something called hexadecimal. Hexadecimal is just another number system, just like decimal or binary. However, each character represents 4 bits. It's a base 16, which means we have 16 different characters to choose from to represent an amount. And it looks a little bit like this. So hex is the middle one. Now you will see it's the same first 10 numbers as decimal. However, if you want to represent the value 10 through to 15, it is just the letters A, B, C, D, E, F. A is always value 10 and F is the largest, which is 15. Work with that at first and hopefully you can slowly work out what would B be. Obviously it would be 11 and all you're doing is counting along. Okay, so how do we convert from hexadecimal to decimal? Well, we have said each character represents 4 bits. So I'm going to convert this into binary. So step 1, convert to binary. Okay, we want to look at them as separate characters at the moment. I'm just going to sort of draw a small placeholder here and here to help us along. So what is 5 in binary? 0, 1, 0, 1. Okay, and what is 2 in binary? 0, 1, 0, 0. So we have our 5 and we have our 2. All I'm going to do is I'm going to join them together, and I've just switched colour here. So we're going to start with this side first. 0, 0, 1, 0, 0, 1, 0, 1. Okay. So all I'm going to do now is I'm going to look at this as 1 byte rather than 2 nibbles. We've joined them together. Okay, so all I'm going to do now is I'm just going to convert them as usual. Okay, so let's add them up. 32, add 4, add 1. That gives us 37. 25, notice I'm not saying 25, in hexadecimal is equal to 37 in decimal. So this is 25 as they are separate characters, where this is 37 as we're using the decimal number. To recap, convert to binary, join the nibbles together, and then convert to decimal. Okay, I'm going to show you another. Okay, so I have F6 here now. Same thing again. I'm going to convert these 2 nibbles. So F is equivalent to 15. Now I know 15 in binary is the max value you can represent with 4 bits. 6 on the other hand is 0, 1, 1, 0. Next thing we're going to do is we are going to join them together into 1 byte. And final thing we're going to do today is we are just going to convert this whole byte as we normally would into decimal. So the addition I'm going to do is 128, 64, 32, 16, 4 and 2. So F6 in hexadecimal is equal to 246 in decimal. Okay, so I have a task here for you. I'd like you to pause the video or maybe rewind if you need to watch me go through it again. I'm going to pop the steps up here just to help you, and then we'll run through the answers in a moment. Okay, so just before we run through the answers, I want you just to keep in mind, typically in paper 2 on AQA or paper 1 on OCR, you will tend to see some conversion questions. They typically are around 2 marks. You get 1 mark for the correct answer, and you get another mark for showing your workings. So it's really important that you are demonstrating the process that you've used to convert these numbers. Often I see students just write the correct answer, and whilst that is true, you are not maximising the amount of marks you're getting in that paper. Here are the answers. Okay, so let's go the other way. Let's go from a decimal number to hex. It's the same sort of steps here. We're going to convert this into binary first. So a lot of the time, you just need to keep in mind binary is sort of the middle step when going between decimal and hexadecimal or hexadecimal to decimal. So firstly, all I'm going to do is write out my lovely placeholders along the top. Okay, so 68, I'm just adding 64 plus 4. Okay, second thing now is we are going to chop in half. So all I'm going to do here is write sort of a half value. So we are now splitting into 2 nibbles. So this side now becomes 0, 1, 0, 0. And this side is 0, 0, 1, 0. Okay, step number 3 is all we are doing is converting these nibbles. So this side is just going to be 4. Remember, 4 in hexadecimal is the same as 0, 1, 0, 0, which is what we have here. And this side, again, is 4. 68 in decimal is equal to 44 in hexadecimal. Okay, so now I'm just going to convert our first one into binary. So step number 1, binary. 128, 42. There we go. Step number 2, can you remember what it was? Okay, we're going to chop these 2 values in half. Oops, my line's gone a little bit funny there. So this side becomes 1, 0, 0, 0, and this side becomes 1, 1, 1, 0. Okay, and then number 3, all we're going to do is convert this side to hex. Okay, 8 in hexadecimal, let's have a little look, is just 8. Remember, it's not going to change, it's always going to be the decimal value as long as you are going up to 10. So this side, we now have 14. So 14 in hexadecimal, well, I want you to be thinking, well, F is the largest number I can represent, that's 15. The one before F is E. That's an easy way to remember. There you go, I've just written the placeholders along the top. So 8 add 4 add 2 is 14. 8E is equivalent to 142 in decimal. Okay, so same thing again. Always rewind the video if you feel like that will help you. Give these a go. I'm going to run through the answers in a moment. Okay, fabulous. Right, next we're going to be talking about binary shifts. Now, all we are doing is we are multiplying or dividing a binary number by shifting either to the left or to the right. Sometimes it's once, sometimes it's twice, and we're going to talk about what that does to the number. So let's say I wanted to perform a binary shift of 1 to this number. Well, that would mean I'm moving it 1 placeholder to the left. all I'm going to do here is basically do one jump along, and I've added a 0 at the end because I've moved it to the left. So what's it done to my number? Well, let's have a little look. It's 13. However, because I've now jumped 1 to the left, this is now equivalent to 26. Now you will notice I've times by 2. Okay, let's try 2 jumps. So 1 jump was times by 2. Let's try 2 jumps. So I'm just going to move them 2 places, 0, 1, and then I've got 0, 0. Okay, so we know the first value was 13. Okay, what does this add up to? Okay, so we've gone from 13 to 52. Well, actually, you will see this is times by 4, and you might be noticing a pattern here. Another jump would be timesing by 8, so on and so forth. So just like when we use our binary placeholder columns, okay, each time we're timesing by 2, however, we perform a binary shift, we're timesing by the power of 2. Okay, so now we realise shifting to the left typically is timesing by the power of 2, so times by 2 for 1 jump, times by 4 for the 2 jumps, times by 3, times by 8 for 3 jumps, times by 16 for 4, so on and so forth. Now going to the right hand side, we're going to go the other way and we're going to divide. So if we did a binary shift of 2, that's going to divide by 4. Okay. Okay, so if I want to just double check that, actually we've gone from 4, 2 jumps would bring it to 0, 0, 0, 1. Actually, yes, 4 divided by 4 is 1. So all we are doing is dividing by the power of 2. Main things to remember here is to the right is division, to the left is multiplication. Here's an exam question, 2 marks. Okay, so all I want to do is run through where you would get the marks. So you would get 1 mark for saying a shift to the left is going to multiply that number. So that is your first mark. Pointing to the left, remember, is multiplication. A binary shift to the left is multiplication. Remember, to the right is division. A shift of 3, well, if we look at this number here, currently this number is 3. Okay, so what I'm going to do is move this 3 times. 1, 2, 3. So we now get 1, 1, 0, 0, 0. 3 zeros there as it's a shift of 3. So we know multiplication is to the left, division is to the right. So we're going to times by the power of 3, which would be timesing by 8. 1 jump would be times by 2. 2 jumps times by 4, 3 jumps times by 8. And we can double check this because this is equivalent to 3. However, this is 24. Well, 3 times 8 is in fact 24. All you'll be asked to do at GCSE is add up 3 ones in 1 column. That is the max that they have specified they will ask you. Okay, so I've just put the rules sort of to the underneath my picture, and all we're going to do is work this out together. 0 and 0 is 0, 1 and 0 is just 1, 0 and 1 is 1, 1 and 1 is, let's check down here, 0, and you're going to carry the 1 forward, 1 and 1 is 0 and 1. So we can always double check our work by quickly converting them along the top. So I've worked out 10 plus 28 is 38, and I've just converted this bottom one, and that also gives me 38. Okay, so I've got the rules on the right hand side again. 0 and 0 is 0, 1 and 1 is 0, carry the 1, 1 and 1, ignore that 0, is 0, carry the 1, 1 and 1 is 0, carry the 1. Okay, so the final thing I'm going to do with you today is I'm just going to show you an exam question. So maybe pause the video now and see if you can add this up. Okay, now we're going to run through it together. I have the rules just on the right hand side here, just to help you. So let's begin. 1 and 1 is 0, carry the 1. 1 and 1 and 1 is 1, carry the 1. 1 and 1 is 0, carry the 1. 1 and 1 is 0, carry the 1. 1 and 1 and 1 is 1, carry the 1. 1 and 1 is 0, carry the 1. So adding all of these numbers up will give us 1, 0, 1, 0, 0, 1, 0. Okay, and if I just wanted to double check this, which I definitely would if I had time in the exam. So this all adds up to 82. Let's double check if that's correct. 1, 2, 4, 8, 16, 32, 64, 64, add 16, add 2, 82. Okay, so typically where you get your marks are, they will normally check you have the first 4 bits correct, that would be your first mark, and then the remaining bits would be your second mark. That's how you maximise your marks on this question. Hopefully this video has been useful to you. There's quite a lot sort of covered, but the best thing I can say is show you're working and practice, practice, practice.